Hello everybody, welcome into another lesson. So today we are going to solve quadratic equations by factoring. And this one here is already factored. You got the quantity of y plus 5 times the quantity of y minus 7. All you have to do is take each of the factors on their own and set them equal to 0. So we have y plus 5 equals 0. Well, y would equal negative 5. Then we have y minus 7 equals 0. Well, then y would equal 7. So you can write it like this: y equals negative 5 comma 7. And that would be your answer. Y would equal negative 5 and positive 7. And I got more examples here. Next we have the quantity of n plus 1 times the quantity of n plus 9. That's equal to 0. So whenever these are equal to 0, you just take each of the factors, you'll set them equal to 0. So take each factor on its own, set it equal to 0. You have n plus 1 equal to 0, so n would equal negative 1. Then you take n plus 9, set that equal to 0, then you would get n equals negative 9. So you can write it as n equals negative 1 and negative 9. And those are your solutions to this. N equals negative 1 and negative 9. Alright, 15n times the quantity of n plus 15, that's equal to 0. Well, still, you're going to take each of the factors, set it equal to 0, start with your 15n, set that equal to 0, well, n would just equal 0. Then take your n plus 15, set that equal to 0, n would equal negative 15. So n equals 0 and negative 15. So far, easy enough. Just take each of the factors, set them equal to 0. Alright, let's see here. 2x times the quantity of x minus 20 is equal to 0. Well, take your 2x, set that equal to 0. Well, x would just equal 0. Then you have x minus 20, set that equal to 0. Well, x would just equal positive 20. So x is equal to 0 and 20. Alright, now this gets a little bit different. We have the quantity of 2t minus 3 times the quantity of 3t minus 2. Those are equal to 0. So you're going to take each of your factors, set those equal to 0. Take 2t minus 3, set that equal to 0. Well, 2t would equal 3, and then t would equal 3 halves. Then take your 3t minus 2, set that equal to 0. Well, 3t would equal 2, so then t would equal 2/3. So in the end, you get t is equal to 3 halves and 2/3. Those would be your two solutions to this. T equals 3 halves and then 2/3. Alright, let's see. We got 2u plus 7, that quantity, times 3u minus 1, those are equal to 0. So just take each of your factors, set them equal to 0 separately. You have 2u plus 7 is equal to 0. Well, 2u would equal negative 7. So u would equal negative 7 halves. Then take your 3u minus 1 separately, set that equal to 0. So 3u would equal 1, and then u would equal 1/3. So the values for u that you get that solve this equation are negative 7 halves and positive 1/3. So u equals negative 7 halves and positive 1/3. Alright, we have 3x times the quantity of 2x plus 1 times the quantity of 2x plus 5 equal to 0. So now we have 3 factors. You're just going to take each of the 3 factors, set them equal to 0 separately. So do 3x equals 0, well, x will equal 0. Take your 2x plus 1, set that equal to 0. Well, then 2x equals negative 1. X equals negative 1/2. And then take your 2x plus 5, set that equal to 0. Well, 2x equals negative 5, so x would equal negative 5 halves. So you'll have 3 answers for this. X will equal 0, negative 1/2, and negative 5 halves. So those are the 3 solutions to this. X equals 0, negative 1/2, and negative 5 halves. Alright, we got m times the quantity of 5m minus 2 times the quantity of 2m plus 5. Those are equal to 0. Well, take each of your factors, set them equal to 0. First one is m equals 0. Nothing further we can do with that. That's one solution. Next, take your 5m minus 2, set that equal to 0. Well, 5m equals 2, so m would equal 2/5. And then take your 2m plus 5, set that equal to 0. Well, then 2m would equal negative 5, so m equals negative 5 halves. So the 3 solutions for this are going to be 0, positive 2/5, and then negative 5 halves. Those are your 3 solutions for m. 0, positive 2/5, and negative 5 halves. Alright, move on a little bit different here. We got y squared minus 3y plus 2 equal to 0. So we got y squared minus 3y plus 2 equal to 0. So this time we have to factor it. up till now, we've dealt with equations that were already factored for us. And today, all of these equations will be factorable one way or another. But there will come a time where we'll deal with quadratic equations that are not factorable, and we'll have to use what's called the quadratic formula, which is coming at a later time in this course. And also something as a side note, in Algebra 2, you're going to learn a theorem called the fundamental theorem of algebra, which tells you that the degree of your equation, in this case 2, that's how many solutions you have in the complex number system. The complex number system is a mix of the real and imaginaries. It's the real and imaginary numbers put together. But for the sake of this course, we're only dealing with real numbers. So that you can expect to have 2 solutions out of this since you have it to the second degree. Okay, but let's factor y squared minus 3y plus 2. And I did do a previous video on factoring these equations. I've done several videos on factoring these forms, so if you missed those or need help with factoring, please feel free to reference those. But for the sake of the lesson, if you're watching this, I'm going to assume you know how to factor. It's going to save us a lot of time. So let's go ahead and factor this here. We have this equation here. Well, the factorization would be y minus 2 times y minus 1. And if you factor this out, if you FOIL this out, you would get exactly the equation here. So when we factor, you get the quantity of y minus 2 times the quantity of y minus 1 equal to 0. Now you just take each of these factors, set them equal to 0 by themselves. Y minus 2 equals 0, so that means y equals 2. Then you got y minus 1 equal to 0. Well, y equals 1. So your answers for this are y is going to equal 2 and 1. Those would give you values of 0. Y would equal 2 and 1. Alright, we got p squared minus p minus 6, that's equal to 0. P squared minus p minus 6 equals 0. Well, we need to factor this here. Factorization is going to be p minus 3 times the quantity of p plus 2. Set that equal to 0. And then you just take each of your factors, set them equal to 0, take your p minus 3, set that equal to 0. Well, p would equal 3. Take your p plus 2, set that equal to 0. Well, then p would equal negative 2. So your 2 solutions for this are going to be positive 3 and negative 2. Those would both give you an answer of 0. Alright, x squared plus 14x plus 48 equals 0. So we got x squared plus 14x plus 48 equal to 0. Well, let's go ahead and factor this. If we factor it, you would get x plus 6, that quantity, times x plus 8. Take those, set it equal to 0. Now you take each of your factors individually, set them equal to 0. X plus 6 equals 0, so x would equal negative 6. Then you take your x plus 8, set that equal to 0. X would equal negative 8. So the solutions you should get for this are -6 and -8. Those will both give you a value of 0 for the equation. Alright, k squared minus 12k plus 35 equals 0. So we got k squared minus 12k plus 35 equal to 0. Well, let's factor this here. You would get k minus 7 times the quantity of k minus 5 equal to 0. Now you just take each of your factors, set those equal to 0. K minus 7 equals 0. So then k equals 7. Then you have k minus 5. Set that equal to 0. So k would equal 5. So the two values of k that you should get would be k equals 7 and 5. Those are the two values of k. Alright, m squared minus 36 equals 16m. We got m squared minus 36 equals 16m. Well, in order to solve this, we're going to have to make the right side equal to 0. Okay? We can only solve if the right side equals 0. You can't solve it any other way. So we got to move that 16m out of the right-hand side, which means we got to subtract 16m from both sides. So if you do that, you would get m squared minus 16m minus 36. And then that would be equal to 0. Now, we can go ahead and we can factor this and set the factors equal to 0. You would get the quantity of m minus 18 times the quantity of m plus 2. Set those equal to 0. So then take each of your factors, set them equal to 0. M minus 18 equals 0. So m would equal 18. Then m plus 2 equals 0. So m would equal -2. So the values of m that you should get are positive 18 and -2. Those would be the values of m that you get, 18 and -2. All right. We got y squared equals 16y. So y squared equals 16y. Well, again, you can only solve if the right-hand side equals 0. So you got to subtract 16y from both sides. If you do that, you'll get y squared minus 16y is equal to 0. Now we can factor y squared minus 16y. To factor that, you factor out a common y. Y times y equals y squared minus, then you just have 16, because y times -16 is -16y. So now you got y times the quantity of y minus 16 equal to 0. Set each of the factors equal to 0. Y would equal 0. Can't do anything with that. Y minus 16 equals 0. So then y would equal 16. So the two values of y that you should get would be 0 and 16. Both of those will give you 0. we got 9k squared is equal to 4k. 9k squared equals 4k. Again, we have to have the right side equal to 0 in order to be able to solve this. So we got to subtract 4k from both sides. If you do that, you'll get 9k squared minus 4k. That'll be equal to 0. Now, to factor 9k squared minus 4k, you could factor out a common k. K times 9k equals 9k squared minus 4. K times negative 4 equals negative 4k, so those are your factors. That'd be equal to 0. Well, set your k equal to 0. That's one solution. Now take your 9k minus 4, set that equal to 0. So 9k equals 4. K equals 4/9. So the values for k that you should get are going to be 0 and 4/9. That would be the answer to this. It would be 0 and 4/9. Alright, we got x squared equals 20x minus 100. Well, we got one thing going right for us. We have the x squared on the left-hand side. That's good. Now, we want to get the 20x minus 100 out of the right-hand side, make that equal to 0. Let's do this a step at a time. Let's subtract 20x from each side. If you do that, you would get x squared minus 20x equals negative 100. We're a step closer. Now you need to get that negative 100 out of the right-hand side, make it equal to 0. So you got to add 100 to both sides. You would get x squared minus 20x plus 100 equal to 0. Now we can go ahead and factor x squared minus 20x plus 100. This turns out to be a perfect square trinomial. So what you would get is x minus 10, that quantity to the second power, equal to 0. If we did the binomial square expansion, you would get x squared minus 20x plus 100. So whenever you have a factor to the second power, what that's telling you is you're going to get the same answer twice. It technically still counts as two answers, but we're only going to list one because it occurs twice. We don't need to list it twice even though it occurs twice. You're just going to take that x minus 10, set that equal to 0, and then x would equal 10. Even though it looks like only one solution, this is actually two solutions because 10 occurs twice. So keep that in mind. Alright, we got 25 m squared minus 16 equals 0. Well, this looks like the difference of two squares. So what you would get is the... Whoops, I want to write in green. I want to write in a different color for working out the problem. What you would get is the quantity of 5m plus 4 times the quantity of 5m minus 4. You would set those equal to 0. So then take your 5m plus 4, set that equal to 0. So then 5m equals negative 4. And then m would equal negative 4/5. Then take your 5m minus 4, set that equal to 0. So 5m equals 4, m equals positive 4/5. Now, whenever you have basically what looks like the same solution, only one positive and one negative, one positive, here's how you can write it. M equals plus minus 4/5. You can write it like that to save yourself a little bit of writing. M equals plus minus 4/5. That denotes that you have two solutions still, but one's positive and one's negative. So this saves you from having to write 4/5 and then negative 4/5. You just do one symbol and then 4/5, the plus minus symbol. Alright, 6n squared plus n equals 2. Well, I can tell you this. We need to get the 2 out of the right-hand side. We need to make the right side equal to 0. So you're going to have to subtract 2 from both sides. If you do that, you get 6n squared plus n minus 2 equal to 0. Now, we got to come up with some factors here that would make the middle term n. Well, we're definitely going to have 2n and then 3n. I'm going to say 2 goes here, 1 goes here. Alright, so you get 6n squared plus 4n minus 3n, that gives you the positive n, then gives you negative 2. Okay. So your factors are going to be the quantity of 2n minus 1 times the quantity of 3n plus 2 equal to 0. Take each of those, set them equal to 0, you would get 2n minus 1 equal to 0. So then 2n equals 1. N would equal 1/2. That's one solution. Now take your 3n plus 2, set that equal to 0. 3n equals negative 2. So n would equal negative 2/3. So your two solutions for this are going to be n equals 1/2 and negative 2/3. That's exactly what you would get, is positive 1/2 and then negative 2/3. Alright, we got 3x squared plus x equals 2. 3x squared plus x equals 2. Well, that 2 has to disappear out of the right-hand side. The right-hand side's got to become 0, so we got to subtract 2 from both sides. So what you would get if you did that is 3x squared plus x minus 2 equal to 0. Now we just got to find some factors that would make that middle term 1x. So of course we're going to have x and then the 3x. I'm going to say 2 goes here, 1 goes here. 3x squared plus, that'd be minus 2x plus 3x. Yep, that would give you positive x minus 2. All right. So your factors of this are going to be the quantity of x plus 1 times the quantity of 3x minus 2 equal to 0. Now take your x plus 1, set that equal to 0, x equals negative 1. Then take your 3x minus 2, set that equal to 0, so 3x would equal 2, then x would equal 2/3. So the solutions to this, x equals negative 1 and then positive 2/3. Alright. We have 8u to the third minus 2u to the second equal to 0. Well, the right-hand side equals 0. That's going to help you. Now, what you have to factor out here, between both the 8u to the third and the negative 2u to the second, there's a common 2u to the second. We can factor that out. Now, see, 2u to the second, that'd be times the quantity of 4u, because 2u to the second times 4u is 8u to the third, then just minus 1. Alright, so you have the quantity of 2u to the second times the quantity of 4u minus 1 equal to 0. Now you just take each of these factors, set them equal to 0. Take your 2u to the second, set it equal to 0. Well, u would just equal 0 there. 0 twice. Technically it occurs twice. Then you have 4u minus 1. That'd be equal to 0. So then 4u equals 1. U equals 1/4. So your values for u that you would get are 0 and positive 1/4. Alright. 7x squared equals 18x minus 11. So we got 7x squared equals 18x minus 11. Well, the 18x minus 11 has to disappear out of the right-hand side. That's got to become equal to 0. Let's do this one step at a time. Well, I didn't want to do that. Let's subtract 18x from both sides first. You would get 7x squared minus 18x is equal to negative 11. Now we need to get that negative 11 out of the right-hand side, make that equal to 0. So what you have to do now is you would get 7x squared minus 18x plus 11 would be equal to 0. Now we got something we can factor. So let's go ahead and factor this out. Take your x, take your 7x. See, minus 11, minus 1, minus 7x, minus 11. Yep, alright, that checks out. So your factors of this would be x minus 1 times the quantity of 7x minus 11. So set each of those factors equal to 0. X minus 1 equals 0. X would just equal 1. And then you have 7x minus 11 equals 0. So then 7x equals 11. X equals 11/7. So the answers you should get for this, x would equal 1, 11/7. We're not terribly far from done with this today. Alright, let's move on here. Got about 6 more examples. So we have 4x to the third minus 12x to the second plus 8x equal to 0. Alright, so now we have an equation to the third power. That tells you there should be 3 solutions then. So let's look for a common factor to pull out of this to factor out. Well, it looks like 4x would be a common factor. That would give you 4x times a quantity, 4x, let's see, times x squared. 4x times x squared is 4x to the third. X squared minus 3x, because 4x times negative 3x is negative 12x squared, plus 2. 4x times 2 is plus 8x. Okay. So we got so far the 4x times the quantity of x squared minus 3x plus 2. Well, the x squared minus 3x plus 2 will definitely factor further. So you'll still have 4x on the outside times the quantity of x minus 1 times the quantity of x minus 2. That's the factorization of x squared minus 3x plus 2. You would get the quantity of 4x times the quantity of x minus 1 times the quantity of x minus 2, set that equal to 0. Now take each of your factors, set them equal to 0. 4x equals 0. Well, x will just equal 0. X minus 1 equals 0. Well, x would just equal 1. X minus 2 equals 0. Well, x would equal 2. So your 3 solutions to this would be x equals 0, 1, and 2. Those would be your 3 solutions to this equation. X equals 0, 1, and 2. See, 2n to the third minus 30n squared plus 100n equals 0. So we got 2n to the third minus 30n to the second plus 100n equals 0. Let's look for common factors we can pull out of the left-hand side. I'm going to say 2n's a common factor. So then you'd have 2n on the outside. Let's see, you'd have n squared, because 2n times n squared is 2n to the third, minus 15n. 2n times negative 15n is negative 30n squared. Then you'd have plus 50. 2n times 50 is 100n. Alright. So we got the quantity of 2n times the quantity of n squared minus 15n plus 50 equal to 0. Well, the n squared minus 15n plus 50 factors a step further. You'll still have 2n on the outside. Let's see, you're going to have n minus 10 times the quantity of n minus 5. So yes, this reduces to 2n times the quantity of n minus 10 times the quantity of n minus 5. All 3 of those equal to 0. So now take your 2n, set that equal to 0. Well, n will just equal 0. Take your n minus 10, set that equal to 0. n equals 10. Take your n minus 5, set that equal to 0. Well, n equals 5. So the three answers you should get for n are 0, 10, and 5. Those would be your three solutions to this equation, 0, 10, and 5. Let's see. I think we'll just do two more. We'll do two more. Alright. So we got y to the fourth minus 10y squared plus 9 equals 0. Alright. So y to the fourth minus 10y squared plus 9 equals 0. This is to the fourth degree, so that tells you there should be 4 solutions. Well, let's factor this here. We could treat this like a quadratic. You would end up getting y squared minus 9 times the quantity of y squared minus 1. Set each of those equal to 0. Yep, you would. That's what you would have. But each of these factors is the difference of two squares, so they do factor further. Y squared minus 9 factors into y plus 3 times the quantity of y minus 3. Then y squared minus 1 factors into the quantity of y plus 1 times the quantity of y minus 1. So we have 4 factors here. We have y plus 3 times y minus 3 times y plus 1 times y minus 1. Just take each of your factors, set them equal to 0. Y plus 3 equals 0, so y equals negative 3. Y minus 3 equals 0, so y equals 3. Y plus 1 equals 0. Y equals negative 1. And then y minus 1 equals 0. Y equals 1. So your 4 solutions for y are going to be plus or minus 3, and then plus or minus 1. And those plus or minus denotes that you have a positive and negative on each. So this is really 4 solutions. Alright, one more. We have u to the fifth minus 13u to the third plus 36u. All that equal to 0. So you get u to the 15th, I'm sorry, u to the 15th, whoa, u to the 5th minus 13u to the 3rd plus 36u equal to 0. Having a 5th power tells you there should be 5 solutions. So, let's go ahead and start with factoring out a common term. Definitely u is a common term. So you factor out the u, you would have u to the 4th. You have u to the 4th. So u times u to the 4th is u to the 5th minus 13u squared. U times negative 13u squared is negative 13u cubed plus 36. U times 36 is 36u. So these factors check out. Well, the u to the 4th minus 13u squared plus 36 factors further. You're still going to have u on the outside, but you'll have the factors of u to the fourth here minus 13u squared plus 36, you would get u squared minus 9 times u squared minus 4. Well, the u squared's minus 9 and the u squared minus 4, those factor even further. You'll have u times the quantity, let's see, u squared minus 9, that'd be u plus 3 times the quantity of u minus 3. And then u squared minus 4, that factors into u plus 2 times the quantity of u minus 2. So now we have 5 factors of this equation that we have to set equal to 0. Take your u, set that equal to 0. That's good. U plus 3 equal to 0. So u would equal negative 3. U minus 3 equals 0. U would equal positive 3. U plus 2 equals 0. U equals negative 2. And then u minus 2 equals 0. So u would equal 2. So your 5 solutions to this are going to be u equals 0, plus or minus 3, and then plus or minus 2. There really are 5 solutions here. I just wrote the plus or minus to save us some writing. So u equals 0, plus or minus 3, and plus or minus 2. So that's been it for factoring and solving equations involving factoring. Next lesson, we're going to start diving into fractions, and algebraic fractions at that. We will work on simplifying them first in the next lesson. So I hope everyone has a good day. Take care.